students. Welcome to the 22.2 Areas of Regular Polygons video notes. Okay, so I thought that this would be a little bit easier so that I could actually explain as we go through the notes instead of just posting the note page for you to look through. Okay, so we start with this regular polygon here, and what we know about regular polygons is that all of the sides are the same and also all the angles are the same. So that means that to find the area, if I cut this thing up into a bunch of triangles like this, then we can just find the area of one of those triangles, and since all those triangles are the same, we can just multiply it by how many triangles there are to get the area. And we know how to find areas of triangles, so we're going to start there. Okay, so this example is going to be done with a hexagon. You could do this with any regular polygon, just adjust for the amount of sides that there are. So here we go. So each of these angles on these triangles are going to be the same since all the triangles are the same. And since we make it all the way around the circle with triangles here, those angles are going to add up to 360 degrees. So the measure of just one of these angles is just 360 divided by how many there are. So for the hexagon, it's 360 divided by 6, since there's 6 sides and 6 triangles. If it was another shape, it would just be 360 divided by the number of sides on that shape. Okay, so that's how we get that angle. So in this case, it's a 60-degree angle. And now we have to figure out the area of a triangle. So area of a triangle formula that we learned last week is base times height divided by 2. So for base times height divided by 2, that means we need to know the base and we need to know the height. So when we're given a problem like this, usually you're either going to be told the base or the height, one of the two. So in this case, I'm going to say we're told the base, and I'm going to say the base is 10. So that's just going to be part of the given information for the problem. Alright, so in this case, the height, dropping down the height, cuts this into 2 equal pieces. So if the whole thing is 10, then each of these equal pieces are 5. Okay, so to get a little bit of a better look at this, let's take this triangle right here and make it a little bit bigger. So we've got this side is 5, this is the height that we don't know, and then this angle right here is just half of the big angle. So this height cuts the triangle, or cuts this angle also into 2 equal pieces. So it cuts the base into 2 equal pieces, and it cuts the angle into 2 equal pieces. So if it was 60 for the whole thing, half of it's just going to be 30 degrees. Okay, and since this is a right triangle, because the height is perpendicular to the base, as always, we can use trigonometry to solve for the height. So to this 30-degree angle, 5 is the opposite side, h is the adjacent side. So we can go opposite over adjacent, which is tangent. So we're going to use tangent of 30 equals opposite over adjacent, so 5 over h. So we're going to type tangent of 30 into our calculators. So we go tangent 30 degrees, and we should get 0.5774. So tangent of 30 is 0.5774, and that's still equal to 5 over h. And then we can cross multiply here. So 0.5774h equals 5. Then we can divide by 0.5774. And we get that the height is about 8.66. Okay, so that's the height of our triangle from up here, 8.66. So now that we have the base and the height, we can use that to find the area of the triangle. So back here to our area of a triangle, It's base times height divided by 2, so the base was 10. times the height, 8.66, divided by 2. So 8.66 times 10 divided by 2, all in our calculator, equals 43.3. So that's the area of one of these little triangles. And since it's a hexagon, we have 6 of these triangles in here. So we're going to take this to find the area of the polygon, and we're going to multiply it by 6. So 43.3 times 6 is equal to our area of hexagon. So times 6, and we should get 259.8 units squared. Okay, so that's a lot of work though. We can go through this whole process each time we want to find the area of a polygon, but there are a couple of formulas that we can use to make this a little bit easier on ourselves so that we don't have to do this every single time. Because you could, and we want to make sure that we know how it works. But now that we do know how it works, let's see what the formulas are. So, in order to do the formulas for areas of regular polygons, we have to learn a new word. And the new word is apothum. Sounds kind of like saying opossum, but with a lisp. So, apothum. And apothum is really just the word for the height of these triangles that we were using. So this distance from the center to the side of the hexagon is really the apothum. So let's show this on a different shape. So if we had a pentagon instead, and this will work with any polygon, the apothum is just that distance right there. And it's spelled A-P-O-T-H-E-M, apothum. Okay, so to find the area of a polygon, it's equal to the perimeter, P, times the apothum, divided by 2. So this is the perimeter, this is the apothum, divided by 2. Okay, so sometimes the hard part here is finding the apothum. So that was what we did with this whole picture up here, finding the height of that triangle. And actually, there's a formula we can use for that too, that takes all of this work and puts it into one step. And it generalizes it for for any shape, or any regular polygon, not just any shape, I guess. Okay. So A for apothum equals the side length divided by 2 times tangent of 180 divided by the number of sides. So in all of these equations, S is going to be the side length, and N is going to be the number of sides. Okay, and then the formula for perimeter is just if all of these sides are the same length, perimeter is the distance around the outside. So it's just the side length times the number of sides. So for perimeter, that's just side length times number of sides. So S times N, using this same notation right there. Okay, so now that we've got some formulas that we can use to cut down on our work a little bit here, let's try one. So we're going to do a pentagon and pretend that all the sides are the same because, you know, I'm not a great artist here. And we're going to be given the perimeter this time. So this time the perimeter is 75 inches. So there's 3 things that you could be given. You could be given perimeter, you could be given side length, or the apothum. And for whichever one you're given, so in this case we're given the perimeter, 75, you need to find the other two. Alright, so then we're given the perimeter, but we need to find the side length and the apothem. You could be given any one of these three things, and you would need to find the other two. So, to go from the perimeter to the side length, we just take the perimeter and divide by how many sides there are. So, 75 divided by 5, since there's 5 sides, which gives us 15 inches for the side length. So that tells us that this side is 15 inches long. Okay, and so then we need to find the apothem, which is just the height of this triangle right here. And we have our formula to find the apothem. We could also think of this angle right here as 180 divided by the number of sides. So in this case, 180 divided by 5, which is 36. For that angle. And then, since this cuts this in half, this would be 7.5. This would also be 7.5. So we could go about it that way with the triangle. But this kind of cuts out that legwork of the triangle. We can just plug in the side length and the number of sides, and that will also tell us the apothem, or the height of that triangle. So we could go side length over 2 times tangent times 180 divided by 5, since there are 5 sides. And we want to make sure we type this into the calculator just like this, with the parentheses and everything. Otherwise, it will think it's 15 divided by 2 and then times tangent. So we go 15 divided by parentheses 2 tangent of 180 divided by 5. And we get that the apothem, when we do all of that, is 10.32. Okay, so now we have the perimeter and we have the apothem, and we can just plug that into, we can plug both of these things into the area equation if we want to. Or we could also just take the side length and the height, or the apothem, and find the area of this triangle and then multiply it by how many triangles we have. So I'm going to do it the triangle way first. So we could take the side length, that's the base. So 15 times the apothem, because that's the height, divided by 2. So 15 times 10.32 divided by 2, which is 77.4. And then, since that's the area of this little triangle, we could take that and multiply by how many triangles there are. So 77.4 times 5, since there's 5 sides, so there will be 5 triangles. And we would get 387 for the final area of that pentagon. Or we could take 75 and 10.32 and plug them into this area formula. So 75 for the perimeter times 10.32, all divided by 2. And we would get the same exact thing. We would get 387. And this is going to be in inches squared. So either way that we do it, we'll get the same answer right there. So there's 2 ways.
Thanks, Halford. Will you please report to the...
So there's 2 ways that we can get this answer. But we get the same answer either way. So if you prefer to think of it as triangles, finding the area of one triangle and then multiplying it by 5, you can. Or if you prefer to think of it as perimeter times the apothem divided by 2, you can do it that way too. It doesn't really matter which way you do it. All right, so that's our notes for today. I'll also post this as a PDF, but I would encourage you to watch the video through just to get the explanation of the notes. All right, now go do your homework. Have a good week.